Hey everyone, in this lesson we are going to begin setting up our network, but before we actually jump into the code, we first of all need to create a little UI window, which is where we can do a number of things. We can enter in a username, an IP address, a port, and then also have two buttons for start server and join server. That is going to be the little interface we're going to have in order to either start a server or join an existing one. So to begin, I'm going to create a new node. And this is just going to be of type node, so nothing special. And I'm going to call this one network. Now, inside of this network node, this is where we're going to attach our network manager script. But before we do that, we need our network UI. So I'm going to right click, add child node. I'm going to search for a panel. And this panel here is just going to be in the center of our screen. So we can make it something like that. And then inside of here, we are going to be stacking a number of different buttons. We're going to have two buttons and two input fields. So I'm going to rename this to be Network UI. And then what we can do is we can create a button. So I'm going to right click on Network UI, add child node. We can search for button. This is going to appear at the top right corner. We can just drag it out a little bit here. We're not going to be going too much into Godot's UI system as that is prerequisite knowledge and it's not really important for the course. Kind of want to get over this stuff early on. So I'm going to give it some text, which is going to say start server. And I'm going to rename the button to be start server button. Now, we could just go ahead and copy and paste this down like that, but it's gonna take some time to orientate them and make sure the pixels are in line. So what we can do instead is utilize a VBox container. Now, a VBox container is basically a control node which will automatically arrange its children nodes in vertical ascending order. So if I right click on Network UI, add child node, look for a VBox container, create that. Just basically make it the same size as the panel and then drag in the start server button. You can see it's going to automatically snap its size and position here. Now if I duplicate this, you'll see that they're going to be added underneath automatically, which is great. So I'm just going to decrease its size here a little bit so it's not hugging the edges. And then what we can do is for our second button, I'm going to call this one join server button. And the text here is instead going to say join server. Now next we need two input fields. Now for these we are going to create line edit nodes. So if I create a new child node as a child of the VBox container, I can look for line edit. And a line edit is basically a single line input field. So we'll create that. I'm going to call this one our IP input. And then on the right hand side of the inspector, the only thing we're going to change is the placeholder text, which is going to basically say IP address. So we're basically just telling the user to enter in an IP address. We can then duplicate this one with Control D. This is going to be our port input. And we are going to set the placeholder text to say port. And then finally, we have one more, and this is going to be for our username input, okay? And this is where the player is going to give themselves a name for the game. So here we'll just say type a username, and there we go. So now if we press play, you can see that we can click these buttons, we can enter in an IP address, enter in a port, enter in a username. One thing you may also notice is that the UI actually appears beneath the clouds, and that's because of the way we have the ordering set up. So if I select the Network UI panel, I'm going to go over to where we have ordering and change the Z index to be, we'll just say about 99, okay? So that's going to appear above everything that we ever create. Let's also clean this up a little bit, so I'll drag the VBox container down here, drag the Network UI panel as well, and then we might even want to properly adjust it so it's in the center, like so. Now, what IP address and what port are we going to be using? Well, when we actually eventually create the server and utilize it to test it on our local machine, so if for example we want two versions of the game on our computer, the way that we can connect from one to the other is by using the localhost IP address, and this is just going to be localhost. Now, there are certain things called internal and external IP addresses. An internal IP address would be if you want to connect to other people on the same network as you. So if, for example, there's another computer in your house that you want to connect to, you would enter your internal IP address or their internal IP address if you want to connect to them. Whereas if you want to connect to a computer outside of your network, maybe in another city, for example, you would have to use your external IP address. And then for port, Godot multiplayer by default uses the 8080 port. So do make sure that if you want to utilize that with an external network, that you do go ahead and port forward the 8080 port. And then of course we can enter in a username here that we want to use. And then we would click either start server or join server. But at the moment, none of this really works. We're just setting up the foundation for the next lesson in which we actually begin connecting computers together. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be setting up our network manager script. Now, the network manager script is going to be in charge of creating a server and connecting clients to that server. We are also going to be setting up a number of different functions that will be called when certain things happen. For example, when a new player connects to the server, a function will be called. When a player disconnects, when connection has failed, when the server is disconnected. We'll have all of these different callback functions, so we'll be able to keep track of when certain server events happen. So for this, I'm going to select our network node that we have created and then go to the inspector and create a brand new script. Now, make sure this is inside of our scripts folder, and this one is just going to be called network manager. Okay, and there we go. Now, inside the network manager here, we are not going to be using the process function, so we can get rid of that. We will be using ready, but we won't actually be adding any code inside of it until later on, as this will be interacting with our game manager, which is something we'll create in a future lesson. But for now, let's start with some variables. So the first variable is going to be a constant variable. Now, a constant variable is basically one that cannot change. Now, this is great if you want to just hard code some numbers to reference later on. So to create this, instead of typing var, we're going to write const, and then I'm going to call this max_clients. Now, general practice is to use capital letters when defining constant variables. This is going to be of type int, and I'm going to make this 4. This is going to be how we will define the maximum number of clients who can connect to the server at once. So this basically means we can only have up to 4 players in our game. Then what we're going to do is basically create a reference to each of the different input fields that we've created for our IP, port, and username, as well as our overall network UI, as once the server is created, we will want to basically disable that. So I'm going to create an onReady variable. That onReady tag basically means that whatever code is run, or whatever code is typed down after the equal sign will be run just before the ready function down here. So I'm going to call this one network UI equals, and I'm just going to drag in the network UI node and place it here, and it's going to create a reference to it. We then want to have one for our IP input. So IP input here equals the IP input. That's going to add that there. Another one for our port input. And we aren't going to be having one for our username input because the username is just going to be set instantly when we type it out. So as a matter of fact, let's select the username input, go up to where we have node, and then go down to where we have the text changed signal. This gets called whenever the text in the input has been changed. So every time we type a letter or type a backspace, this signal will be called, sending over the text. So I'm going to double click on that, and then we are going double click on that. We then want to select our network node. So select the network node and click connect. This is going to create the onUsername input text changed function, which will send over the new text as a variable. And basically what we want to do here is first of all just create a variable called local username of type string, and down inside of this function is where we will set it. So local username equals new text. Now, why are we doing it this way? Well, basically, when we are on the little menu screen here and we type in a username, that will then be assigned straight away to this variable here. Then when we start the server, we need to access instantly these other two input fields. So that is why we are having those as variables, because we don't really want any sort of weird changes going on, okay? And then what's going to happen is once the server has started and your player has spawned in, we will then send this local username over to your local player, and it will then be assigned on that player node. Okay, so that's why we are just temporarily storing it here in the network manager. Now, the next step is going to then be creating our functions. So we're going to, first of all, go down here and create a function called start host. So we'll go func start host, and we'll just enter in pass for now because we're going to create one more function, and that one is going to be called start client. Now, what is the difference between these two things? Well, when we click on the start server button, that is when the start host function is going to be called. Host basically meaning that you are the one running the server on your computer, okay? You're going to be acting as both the client and the server. So basically people are then going to be connecting to you. Now, otherwise, if we click on join server, this is then going to call the start client function, joining whatever IP we have entered in at whatever port we have entered in, okay? So start host if you want to be the server, start client if you want to join a server. Now, these two functions are going to behave very similarly, so let's go ahead and fill those in now. So over here with start host, we basically want to create a variable called peer. Now, a peer is essentially just a client, and we are essentially initiating a new multiplayer peer. So we'll go equals enet multiplayer peer dot new. So create a new one of those, and then we need to call this peer's create server function. So peer dot create server, and then we need to give it a port and the maximum number of clients. So here for the port, I am simply going to get the port input dot text. Now, the issue with this is that the text is of type string, whereas the port needs to be an integer. So what we can then simply do is just cast this string to an integer by writing int, and then in the two brackets here, we enter in a string, and it will basically convert this text to an integer number. Then we can go comma, max clients. And that's all we need to do for that line of code there, okay? I'm just going to zoom out a little bit so we can see it a bit easier. So peer.createServer, this is going to initiate a server at this port with this number of clients. Now, you may be wondering, where is the IP address coming into play? Well, since we are creating the server on our computer, we don't need to provide an IP address as it already knows what that is. Then what we're going to do is we are basically going to access sort of the global multiplayer class that Godot provides, which is just multiplayer. And then we want to go .multiplayer peer equals peer. So here we are essentially assigning this new peer to be our multiplayer peer. Now, that is going to basically create a server and allow people to connect to it. Down here in start client, we want to do something very similar. We want to create a variable called peer and initialize that as a new enet multiplayer peer. Then what we want to do is write down peer, and we want to call the create client function this time. Now, we want to send over the IP address as a string. So here we can go IP input.text, and we then want to give it the port as well. So we'll go int and sending over the port input.text. Okay. So there we are. When we are creating a client or when we want to connect to a server, we need to provide the IP address and the port. The IP address is basically like your house address, so that our computer knows where to look in the world or in your local network for the server. And then the port is basically the little key to access the correct door in that house. Okay. Now, the next step after this, of course, is to then go multiplayer.multiplayer peer equals peer. Now, we are also going to be creating a number of different callback functions. Now, these functions are going to be connected to signals that will basically be called when certain things happen. For example, the host here is going to have two different callback functions, on player connected and on player disconnected. Basically, when a new player joins the server, they will be notified, or when a player disconnects from the server, they will be notified. The reason why we want this is because when a new player joins the server, we as the server need to spawn in a new player object. Or when the player disconnects from the server has to go ahead and delete their player object. Down here with Start Client, they are going to have 3 different custom callback functions. One for when they have connected to the server, so they know personally that, okay, we are now in a server. One for if the connection has failed, so if, for example, they entered the wrong IP address, that would call. And then server disconnected, which will be called when the client disconnects from the server. So if there's any single player settings, or if you want to go back to the main menu, you can do it there. And we'll be setting up those functions in the next lesson. So thanks for watching, and I'll see you all then. Alright, welcome back everyone. Let's continue on with our Network Manager script by creating those little callback functions that will be called for the host or for the client. So the first one down here is going to be a function called onPlayerConnected. So here we'll just go onPlayerConnected, and this is going to have an ID which is going to be of type int. Now, like I said, this function is going to be called on the server whenever a new player has joined. Okay, so this, for example, will be where we want to spawn in a new player's character object. We then have another one down here for when they disconnect. So func on player disconnected, which will have an ID as well. Now this integer number, which is an ID, is basically going to be how we can identify the player that is either connecting or disconnecting. Whenever a new player joins the game, they will be given an ID, which is just going to be a random positive integer number. Now the server's ID is always going to be 1, okay? So if you see an ID of 1, that means that is the server, and anything else is going to be an ID for another player that has joined. Now we need some callback functions that will be called when the that will be called on the client. So we'll have one called function connected to server. This won't be sending over any ID because this will only be called on the client that it applies to. We then want one called connection failed. This is going to be called whenever the client tries to connect to a server but it fails. So for example, if you enter the wrong IP address or the wrong port, or if the IP address doesn't really work, if it's not being port forwarded correctly. And the final one is going to be server disconnected, and this will be called when the server gets shut down and the player gets kicked out. Now let's actually connect these up to their appropriate signals. So what I'm going to do is I'm going to go up to our start host function, and inside of here I'm going to go multiplayer.peer_connected.connect, and we're going to send over the onPlayerConnected function name. We then want to do the same for onPlayerDisconnected. So multiplayer.peer_disconnected.connect, and then we'll go onPlayerDisconnected. Okay. So those two functions are now set up for the host to run. Then we'll have the start client function, which will connect these last three here. So for that, we can simply go multiplayer.connected to server.connect, and then send over the connected to server function. We then want to do the same for the other two as well. And there we go. So if I zoom out here a little bit, you can see that this is what it looks like. Oh, and we are getting an error. That's because I just haven't finished off the function there. There we go. And yeah, there we go. So that's everything written out for us right there. Now, the next step is going to be testing this out to see if it works. Now, first of all, we need to connect these two buttons, our start server and join server button, to these start host and start client buttons, functions I mean. So I'm going to select start server, and then in the inspector, go over to node, and we're going to connect the pressed signal. So I'm going to double click that. We are then going to find our network node here, but instead of creating a new function, we're instead going to click pick, and we're going to choose the start host function right here and click OK, and then connect that. So now you should see next to start host, we can see that it is connected to a signal. The same thing we want to do for join server. So pressed, go ahead and find our network, click pick, start client, connect, and there we go. Now, if we save this and press play, we can go ahead, enter in an IP address. We don't actually need to enter an IP address, but we'll enter in a port 8080 and click Start Server. And, well, nothing's really going to happen because we don't actually know if we are connected or not. So, two things. First of all, let's actually go ahead and give these IP address and port some default text. So for the IP address, I'm going to set the text property here to be localhost, and I'm going to set the port to be 8080, just so that we don't have to type it in each time. Now, inside of our script, let's go down to where we have the onPlayerConnected function here, and basically we are going to print out the player's name. So we're going to go player %s join game, with that %s basically being converted to the ID. We then want to do the same thing for onPlayerDisconnected. So down here, onPlayerDisconnected. And then for the other two, we want to, of course, have one for when they have connected to the server, and one for when connection has failed, and finally one for when the server has disconnected. Now, once a client has connected to the server, we want to disable the network UI. So here we'll go network UI.visible equals false. And then down here, when they disconnect from the server, we want to enable it again. Now, also up here when we start the host, since those two functions aren't going to be called for them, we need to go ahead and disable the network UI for the host once they have started the server. So now if we save that and press play, we should be able to click Start Server, and once again you'll notice that nothing is printed out to the output, okay? But what we can do is try and connect another server or another player to this server. So how do we do that? Well, first of all, we need to be able to run two instances of this Godot game at once, and right now there's no real button for that. We can sort of reload it, but that's not going to do anything. Instead, what we need to do is go up to where we have debug, and then go down to customize run instances. Here, we basically want to change the number at the top left to be 2, so we can increase that by 1 like so. Oh, first of all, enable multiple instances, then set that to be 2, and then click OK. Now when we press play, you'll notice that there are two versions of our game being launched, okay, in two separate windows, so we can just drag them over. And also, if we go down to the debugger, open that up, you'll see that we have now session 1 and session 2, so we can see individual error messages being printed out for both of them. But if we are printing just normal messages like we're doing here, then they will both be printed out to the output. You can see we have these two sort of engine information messages being printed twice because we are running two instances. Now if I open these up again and I start the server on the left one, you can see that, well, nothing really happens, but on the right hand side, if I enter in the localhost IP address, enter in the right port, and click join server, you'll notice that down here it says connected to server, and it says player with its ID has joined the game. So these two games are now connected to the same server. So what can we do from there? Well, on the server side, we can spawn in an object and have that appear in the other client's game, and then have it move around, sending over that information. There's really so much stuff we can do. So what we are going to do in our game is when a player joins the server, they are going to have their little player character spawn in, and they will then be able to move it around freely. So in the next lesson, that is what we are going to explore. So thank you very much for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be setting up our network player. Now this is going to basically be the scene that will spawn in when a player joins the game. So each player is basically going to have control of one player scene, and this is essentially going to be our plane which we can fly around. So let's go ahead and actually create this now. So what I'm going to do is I'm going to go down to our file system. I'm going to right click on the scenes folder, and I'm going to create a brand new scene. Now this is going to be not of type 2D, 3D or user interface, so let's click on the little icon on the right hand side here, and we are going to search for character body 2D. This is just going to be the basis for what we're going to use to fly around. So we'll pick that, and we'll give it a name of player, and here we are. Now, there are a number of different nodes that we need to attach to this player. Let's start with the visuals and the collider, because with this player, with this character body 2D node, we must include a collision shape. So for that, what we're going to do is let's actually add the sprite first, just so we can actually see how big the collider needs to be. So I'm going to go down to our sprites folder. I'm then going to go over to ships, and let's this drag in one of the ships. Okay, I'm going to set its position to be 0, 0, so it is centered on our root node. Let's rename this to be sprite as well, just so that we can understand what it is, as we are going to have multiple sprites here. Then what we're going to do is add a collider. So we can click on the plus, look for a collision shape 2D. We can then set this one's shape over to be, for example, new circle shape 2D. And I think this is actually an alright size by default for it. We don't want to make it too large or too small. Now what we can do is add in a shadow, because our plane is going to be flying around. It's going to be nice if we have a little bit of a shadow that gets displayed on the ground. Now, we don't actually have to include lights or set up any rendering that way. Instead, what we're going to do is simply just duplicate this sprite. And to do that, what we're going to do is we're just going to select it, Control D, and then in transform here, we're going to set its position, its Y position, to be 15. What this is going to do is it's going to move it down here a little bit. And then what we can do is actually go down to visibility, modulate, bringing this all the way down to black. So now we have a black shadow, but we also want it to be transparent or translucent. So we're going to set the alpha channel to be 45. So now it is going to be translucent, and it's basically going to appear over everything. Now, also what we want to do is make sure that the shadow is beneath our plane. Now, if you remember, if we go back to our main scene, our tile map here, if I open this up, select our tile map, go over to ordering, you can see the Z index for the tile map is on 0. If we go to the sky haze, go to visibility or ordering, it's also on 0. This is basically just the default ordering here, but if we go to our clouds, you notice that the clouds have an ordering of 1. So basically, we need to put everything we want above the clouds to be on a number higher than 1. So for this, if we go back to our player, let's set our shadow, which we can rename here to be shadow. I'm going to set the ordering on the shadow. Where is that? Let's just go over to ordering. I'm going to set that to be 2. And then I'm going to set our sprite, since we want that to be above the shadow, I'm going to set that to be 3. Okay, so now our sprite is appearing above the shadow at all times. Now, you may be wondering, okay, when our plane is moving around, we are going to, of course, be rotating. We don't want our shadow to be moving like this. We always want our shadow to be directly beneath, and that is going to be managed in the script, where we're actually going to be positioning our shadow each frame. Now, the next thing we need to do is add in a couple more nodes. The first one is going to be a node 2D. So if we create a node 2D right here, this is going to be for our muzzle. So let's rename this to be muzzle. And we'll want to simply just move it a bit above our plane here. This is essentially going to be where we are going to be spawning our projectile. So when we shoot, this is basically going to be the spawn location for that projectile, because we don't really want the projectile spawning inside of our player. It could look a bit weird if we are turning and the projectiles are kind of going off at a bit of a weird angle. Aside from this, we also want to add in another node. This one is going to be a timer node. Now this timer node, we are going to call it the respawn timer, and we aren't really going to be worrying about this too much at the moment, but let's also go ahead and enable one shot. Basically, the respawn timer is going to be started when the player is dead, and then after a few seconds, the timer is then going to deliver a callback to the player script, and then basically inform us that it's time to respawn. So we're not going to be touching this for a bit, but for now, I think we can keep it just like this. Now, there are also going to be two other components or two other nodes that we are going to add, which you probably haven't seen before, and that is because they are, I guess you could say, multiplayer specific in Godot, and these are multiplayer synchronizer nodes. So I'm going to go ahead and create one of those right here, multiplayer synchronizer. I'm going to drag this to the top, and I'm going to rename this to be our player synchronizer. Now, what is this going to do? Well, basically, this node essentially can synchronize certain properties across the network. For example, we want our position to be synced. So on the server, whenever the player is moving to a new position, we want all other clients that are connected to the server to be able to see the updated position. So this little node here is basically going to send over the position from the server to all of the clients. So that is always going to be an updated visual, same as our rotation, and same as many of our other properties that we might want to have in our script, such as our score, our player name, our player ID, other stuff such as our current and max HP as well. Now, what we can then also do is duplicate this node with Control D and rename this one to Input Synchronizer. Now, the difference between these two is the player synchronizer is generally going to be properties that the server is going to be sending to us, whereas the input synchronizer is going to be values that we as the controlling client are going to be sending to the server, because the way we are going to control this plane is not going to be locally. When we are pressing the arrow keys or pressing the spacebar to shoot, that is not going to be information that is processed on our computer. Rather, we are going to be sending those inputs over the network to the server, and then the server is going to be moving and shooting for us, then updating our computer visually with those changes, okay? Now, the reason why we might want to do this is generally in multiplayer, you don't want to give the player full control over their inputs, as, you know, if you're playing with people who might not be a bit fair, they could find ways to cheat their inputs to maybe shoot more times than they should, or etc. like that. So we are going to have the server control all of the movement and the shooting for every single player, okay? All we are going to do on our little computer is going to be sending those inputs over to the server saying, hey, I want to accelerate, I want to turn, I want to shoot right now. The server will check to see if that's possible, and then if it is, it will basically enact those actions and then send that information back to us saying, okay, you have moved, here is your new position. So that is what we are going to do with these nodes here. Now, basically, we don't really need to modify anything in the inspector. The root path is basically just denoting the node that it is basically connected to, which is just going to be our player node, as that's where our script is going to be. Now, the last thing we're going to do is set up two scripts. The first script is going to be our player script, which is going to control its movement, its physics, its shooting, its health, and all of that. And then we are also going to have another script, which is going to be for the local player to synchronize their inputs. So what we're going to do is we are going to go to our scripts folder. Oh, actually, in fact, let's just create them on the nodes. So I'm going to select our player node, and I'm going to attach a new script to them. Make sure we are saving this to our scripts folder, and I'm going to call this one player. There we go. Hop back into 2D. Let's select the input synchronizer now and create another script on there. And here, also saving this to the scripts folder, I'm going to call this one player input. And there we go. So now we have these two scripts, player and player input. The player script, like I mentioned before, is going to control the movement, the health, the respawning, all of the main elements that this player is going to need, whereas player input is basically going to read the local player's keyboard inputs and then send that information over to the server, where in the player script, the server will be able to read that information and then run the appropriate code. Now, in the next lesson, we are going to jump into actually spawning in this player. So when we start the game, we can actually see this player in the game. Okay, so thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be spawning our player in whenever a new player connects to the server, okay? Because this scene is basically going to represent each player. Now, how do we do that? Well, there's a few things we first of all need to go over. First of all, how is the game going to know that when we instantiate a new scene, we want that scene to also be instantiated over on the client's computers, okay? Because by default, if we instantiate a new scene, spawn a new node into our game as a server, the Godot is not going to know if we want that to be just in our local game or in every client's game. So the way we specify that is with a node called multiplayer spawner. So as a child of the network node here that we have created, I'm going to right click on it I'm going to add a new child node, and we are going to create a multiplayer spawner node. And as you can see here, it says automatically replicates spawnable nodes from the authority to other peers. So if we go ahead and create this, you'll see that we need to assign something known as a spawn path. Now, a spawn path is essentially going to be a node, and all of the objects that we spawn as a child of that will be replicated across the network. So for this, I'm going to right-click on network, add child node. I'm going to add in a node 2D, and I'm going to call this one spawnable nodes, or we'll call this one spawned nodes actually. Then on our multiplayer spawner, we simply just want to drag and drop this node into the spawn path property. Now, down here, you'll see spawn limit. This is basically going to be a number that defines the maximum number of spawned objects. So if you have a game and you don't want the players to be spawning in too many things, you might set this to perhaps 50. But for us, we don't really have a limit, so we're just going to set it to 0, which basically means there is no limit. Now down here inside of the auto spawn list, this is going to be a list of all the scenes that could possibly be spawned and replicated over the network. So this is where we're going to put things such as our player scene and our projectile or bullet scenes, okay? Because we're going to be spawning in those bullets as well. So I'm going to click add element, and then we can click on this little folder icon, and we can then search for our player scene right here. So we are essentially telling this node that the player scene is going to be possible to spawn in and be replicated across the network. Now what we need to do is when a new player joins, the server needs to basically spawn in one of these players, and then they need to attach them as a child to this node right here. And that will basically then update all of the clients to display that new object. So we can save this. We can then go over to our script, and we are going to hop in, of course, over to our network manager. Now in the network manager, we need to create two new variables. We need to create a variable that will reference our player scene that we're going to spawn in, and one to reference the spawned nodes because we need to attach the spawned player as a child of this. So I'm going to create a variable called var player scene, and this is going to be equal to preload, and we just then want to go ahead and find our player scene right here. So it's going to preload that into that variable. And then for the second variable, this is going to be an onReady variable, and this is just going to be called our spawned nodes, and this is going to equal that spawned nodes node that we created before. Okay, so this onReady basically means that it is going to assign the variable to the specific node path at the start of the game before the ready function gets called. Now, how do we actually spawn this in? Well, what we're going to do is we're going to go down to where we have the onPlayerConnected function. Now, remember, this is a function that gets called on the server. Remember, when we are starting as a host, we are connecting to this signal here. So whenever a player joins the server, this will be called on the server. And remember, the server is going to be the one in charge of spawning in the players, pretty much spawning in everything, okay? Whenever we want to do something that gets applied server-wide, generally it's going to be the server, the player who's running the server that's going to do that. So we're going to go to a new line, and we are going to create a new variable called player. This is going to be equal to player scene.instantiate, just as we would do normally. And then what we want to do is basically assign its parent. So here we will go spawned nodes dot add child player. Okay, so when a new player is spawned into the game, they will become a child of the spawned nodes node. Now also when working with these multiplayer nodes, we do want to add a second parameter to this add child call. So we're going to go comma, and you'll see here that the next parameter is a boolean for force readable name. This basically means, I believe, that the name is going to be consistent across the network, as that is important, as we do want these two objects, both on the server and on the clients, to be the same. So we're going to define that as true. Now what we can do is test it out. So I'm going to press play. We can then drag these two instances over here to get a bit more room. I'm going to click start server on the one on the left. And you would first of all notice that nothing happens. Now I'll explain why in just a second, but if we go over to our second instance and press join server, you'll see that a player spawns in and actually, well, falls down because we haven't modified any of their code yet, and they still think they're a platformer controller. But you did see on both screens that for a second they spawned in. In fact, let's actually go ahead, select our player, And let's just delete all of the code here because we don't want them falling down, okay? So I'll press play again. I'll start the server. No player spawns in, which is a bit odd, but if I go to the second client and click join server, you'll see that there on screen we have our player spawning in, and they are both replicated on both screens. So that's great. When a player connects to the server, they have their player spawned in. Now, why is the player only spawning in for the client and not the server? Well, remember, if we go back to Network Manager, this onPlayerConnected function only gets called when a player joins the server, not when the server is initially created, okay? Because when we create the server, a client is not joining the server, okay? The client is, I guess you could say, becoming the server. So what we need to do is something that's fairly simple. We just need to go down into the start host function, and we just want to call this onPlayerConnected to basically simulate the host connecting to the server. So we're going to call onPlayerConnected, and we need to send over the host's ID. Now to access your ID, which is unique for each client, we can call multiplayer.getUniqueID, and this function is going to return a number for the ID on your local machine. Okay, so for the host, this is going to be the number 1. So now if we open up output and read the console log when we start playing the game, so if I click start server, you can see down the bottom, player 1 joined the game and we have a plane spawning in. And if I go on the second one and click join server, it will say player 2 billion something joined the game and they connected to the server. And you can see that the planes have been added in, but something a bit strange is the fact that of course they are stacked on top of one another, so it is going to be a bit hard to see. Okay, so in the next lesson, we are going to work with actually setting up our player script a little bit, giving the player an ID, a name, and also a bit more on the network side. Basically, when the player leaves the game, we then want to destroy their plane. Okay, so we'll be working on that in the next lesson.